Hi, this is Jason Merrill at Desmos. This is the second video in a series about integrating the Graphiti dynamic tactile graphics display with the Desmos graphing calculator. In the first video, I showed basic graphing functionality, and in this video, I will show modeling data with a function. So this is the Desmos graphing calculator. I'm actually going to grab data from our tour about regressions. So over here in help, I'll ask for the regressions tour and grab some sample data from a Google Doc. Now I can copy and paste this data into the graphing calculator. And we'll skip the rest of the tour because I'll just talk us through it. So we pasted the data in, and now we have a scatter plot. And I can immediately feel this scatter plot also on the Graphiti. Now, this data came from the height and x position of a basketball shot. So we're going to try and model that with a function. And just to give us a little bit more context, I'm going to go ahead and draw some axes on the Graphiti. Oh, I'll also go ahead and turn on the screen reader here so we can hear how that works.
VoiceOver servers temporarily on the.
So the first thing I want to try and do with this data is just fit a line to it by hand. So
Mark has done undo link is miss button 1.
Let's try y equals
6 Mark
x.
has done undo y 9 equals x expression 4.
So we can, as soon as we plot this line, we can come over to the Graphiti and feel where the line is and where the data is, and that gives us a signal about what we need to do to the line to make it fit the data better. We can also try audio tracing this curve.
Audio trace on. Use arrow keys to navigate. Press H to hear playing graph.
And audio trace shows us that this function slopes up, but it's hard to relate it to where the data is. With audio representations, this is one of the things that we've sort of struggled with, is how do you relate two curves to each other, or how do you relate a curve to some data in a scatter plot? But with a tactile graphic, it's much easier to see the relationship between the two just by feeling them. So, okay, I'm going to try and use a different line to
y equals x
model the data. So let's try y equals x plus 2.
Plus 2. As graph. Press Option plus S for a summary. Press Option plus T for audio.
Okay, and over on the Graphiti, I can feel that that moved up a little bit. It no longer crosses 0, but it's still below the data. So let's try y equals x plus 10.
2 selected. 1 0.
Okay, so that's pretty close, and this is fast enough for me to try something and react to it, which is kind of a cool feeling.
1 0 selected.
So let's try y equals x plus 8.
8.
Okay, so that's pretty good. Now, if we want to get more precision here, we can use Desmos's automatic least square regression procedure. So instead of manually entering an equation, I'm going to look at the names of my data, y1 and x1, and write
y equals
y1
x subscript equals selected.
We use this
Tilde.
twiddle symbol
X may
to
not
mean
be
regress
used as a regression
again.
parameter.
And then mx1 plus b.
M x subscript 1 plus b.
So now Desmos has fitted this curve to the data. We can go hear about some statistics and the regression parameters.
R superscript 2 baseline equals 0.9529 group. R equals 0.97661 group. E subplot M equals 0.918171 group.
So that's the slope of the graph that I calculated, and here's the intercept.
B equals 10.288 group.
So this is a pretty good model. I can feel over on the Graphiti that it goes pretty well through the data points. But it has a couple problems as a model of a basketball. And one of them is it just keeps going up forever. So instead of a line, let's try a parabola. So I'll do a second model. Instead of y1 regressed against mx1 plus b, I'll try y1 regressed against ax1 squared plus bx1 plus c.
Expression 5. Y subscript 1 baseline equals 10L tilde. Sorry, I don't x. A, x. Subscript 1 baseline 2. Baseline plus b, x. Subscript 1 baseline plus c. Has graph and regression. Press tab to access statistics. Press Option plus S for a summary. Press Option plus T for audio trace.
So now we have two different models for this data, and we can feel both of them on the graffiti to see how they relate to each other. So one of them is a nice curved parabola, the other one's a line. We could also try plotting the residuals, which is the difference between the model and the data. So we'll do that for our parabola model. And now I can feel that this model fits the data quite well. All of the residuals are right here along the x-axis. And this shows off one of the really cool things about the graffiti, which is that there's actually a choice about how high the dynamic pins are raised. So in this example, I'm using higher pin heights for the data points and lower pin heights for the model curve. And that allows me to actually distinguish between the two, even when they're very close to each other or even when they fall right on top of each other. So we're really excited about using the graffiti to help students understand modeling data with functions.